can see the problem.
Okay, so
It becomes so easier.
we're
Okay.
doing C
So
and
Kelly
D
is doing C, right? And Jerry is doing D.
for 913.
Okay. Find the write down the. Okay. Okay, that's good.
Times what?
5 is.
5.
So to
You
get
calculate?
0.01, she
Okay.
divided
You know how to do it right there.
0.12
Okay.
Okay,
No,
now
it's
because
not,
it's
it's not
12%
6.
divided by
It's not 6.
It's at
monthly,
60.
which is
Oh,
12.
you don't
That's
60?
how
Yeah.
she got 0.01
Somebody.
times.
Okay,
Okay, so
what
5
you have
times
to do, someone
12.
can do
That's why
that.
she got 60.
1.01, add it to 1.01, raise it to the power. So she wants to retire in 20 years. 1, 2, 3. And she wants to have $1 million here when she retires. Are you with me?
Amen.
Yeah,
Mhm.
yeah.
Now, how to get there?
Yes.
Okay. Well, I said the two ways. It'll be easier to go gradually, right? Every month, every year. Okay.
Mhm.
So call that PMT. Payment. So you make me payment every year. Okay. Payment. So that you will have $1 million in 20 years, and suppose the money grows at 12%. Rate of growth is 12% per year. Now, what will be the amount of payment? How much money will you have to invest every year?
Right.
But is it the future value problem or the present value problem? Okay, we're trying to find the payment.
Okay.
Oh,
But
okay.
do we know
In the future?
this $1 million? Is that the present value or the future value?
That's the
Future value.
That's the future
So
value.
we're doing future.
No.
Okay.
All right.
There is no present value here.
All right. Good.
Okay. Do you see payment in this formula?
Yes.
Okay. How do you solve for payment?
So we need to divide.
When you divide through FVIFA, right? So to find out the payment, we need to divide the future value of annuity by the annuity factor. Okay, so here 1 million at the top over FVA. We don't know FVA, but we can get it from the chart. Is that the right chart? Future value. Yeah, that's the right chart. 12% and 20 years.
72.052.
0.052. Okay. Divide a million by 72.052. That will be answer.
I got 13,878.
Uh-huh.
13,878.
0.87.
87.
Yeah. Point.
Mhm.
I'll make it
No,
89.
point.
Okay. 79.
Okay. Gotcha.
Okay. So your payment will be every year $13,879. 133.33. 133.33. Can you see that?
Yes.
Okay. 133.33. Now divide million by 133.33. 133.33.
That would be if it was 25 years.
It's 7,500
75 point. Okay, $7,500. Okay. This is part year. You have 30 payments. Now, what is the present value of this payment? What is the PV here? Present value of this annuity in time 0. Okay. In time 0, what is the present value of this 30 payments you are making? Say $500. You're making $500 payment every year, up to 30 years. What is the present value of that? Again, there's a long way to do it, there's a short way to do it, okay? So I'm going to show you the long way first. Find the present value of each of these separately, okay? Find the present value of this here, okay? It will be present value of the first payment, okay? Then find the present value of the second payment, individual payment, single payment, okay? And present value of this, present value of this, okay? So you'll get a series of present values, add them up, okay, it will present value annuity. Of each of these payments, in future payments, okay, these are future payments, and the present value of them separately, add them up, and that will be the present value of this annuity. There is a smart way, short way, which is very similar to the future value. PVA would be equal to payment times present value interest factor and I and N. See, it's very similar to the future value annuity problem, except that I replace FV with PV. Okay. Other than that, the two formulas are same. So to find out the present value of this annuity, you multiply the payment you are making by the present value interest factor annuity from the chart, and you will get the present value factor annuity. Okay. Suppose that you win a lottery. Lottery payment says that you will get 20,000 a year every year for the next 30 years. Okay. All the way 20,000 every year you're getting $20,000. Okay. So as you know, that usually the lottery you have the two options. One option is that you can wait until 30 years and collect the full amount. Or what's the other option?
You get lump sum.
Lump sum.
Yeah.
Lump sum. Suppose that you want to go for the lump sum. Now, how much money will you be happy with? Suppose the bank offers you, so it's 20,000 times 30. So you're making what? 200,000? No, 200 million. 200,000. Only 200,000?
Wait, what? 600,000.
Oh, I'm sorry, six. Okay, six. Yeah, right. Okay. Suppose the bank offers you 450,000. Payment. You can take it today, or you can wait until.
That's all they will give you?
Huh?
That's all they will give you?
450. Yeah.
Oh,
Without doing any time fill of money, we don't know.
right.
You can't say yes and no. Okay, we'll have to do some
Oh, we gotta do that.
time fill of money. Okay. This offer is today.
Mm-hmm.
Okay. What do we compare this with?
Oh, so we're trying to find the present value of this,
Okay.
the payment.
I have to find out the present value of this.
Okay.
Okay. So payment is 20,000.
Okay.
Okay. Suppose here we need end is 30. I know that. And what is the rate of interest? Rate of growth? How much money can you earn on your money? Interest rate?
Oh, I don't know.
10%. 10%.
Where you
Easy.
get that from?
Wait, how you got that?
Where you get 10% from?
Oh, it's just-
Oh, you making it up? Okay.
Present bulk annuity of $1. Okay.
10%.
Okay.
Okay, I got it. 94269.
9.4269. Okay. And multiply 20,000 by 9 point. Okay. So that amount of money to you should be worth $188,538.
Today.
Yeah, this is what is this future money is worth to you today only $188,538.
Oh, wow. So period. We took the one.
Dollars, then you should take the offer.
Okay.
Okay. Come down,
I'm gonna pay like 10K down.
10K down.
Is that, would you
How
do
about-
less?
How about 2K down?
5.
5.
Yeah, like 5.
5K. Might as well. do
Okay.
it.
So this 35,000 you need money, right?
Mm-hmm.
This you need to borrow this money. You're borrowing this money when? You're borrowing this money today. And how long is this loan for?
No.
60 months? I don't know. 60. Okay. tell me, why did we put this amount, $35,000, which you're borrowing today?
But if
That's
we're
what I
borrowing
think.
it like right now, wouldn't that be the present value for borrowing it right now?
Today.
$25,000 is the present value, and you're going to pay it off every month, right?
Okay.
And the present value of this payment would be equal to $35,000. So which formula should I use? Future value or the present value?
Oh.
Future.
The future value.
Future value.
Future value. Okay. Okay. Let's see if I can find out.
But I say like,
Okay. Tell me, do we know FIA?
No.
We don't know that. Do we know payment?
No.
Well, then if you don't, with this one equation, if you have two unknowns, you can solve it.
Oh, so it's the present value.
So, do we know this PBA?
yeah.
Yes.
Yes.
$35,000.
Payment, we don't know that.
No.
We know this, we can find out this. Suppose this payment is for 60 months, and what rate?
Sorry.
Rate would be? Well,
6 or no? Yeah.
So it has to be monthly rate. Monthly rate, let me see what's the rate, maximum months we can have on this chart. 55, okay.
Yeah.
Suppose that is a 55 month loan, okay?
Okay.
Instead of 60, it's 55 months.
I was trying to do two.
Okay. So, 55
So you just pick a random one.
and 1%, okay? 1% monthly.
I need that.
That will be 12%. Actually, I'm going to show you how to use the Excel also, okay? So, from the chart, find out this 55 months. Is it present value? Okay. Okay. So 1% and 55, number is 42.1472. So, to find out the payment, divide through by 42.1472. Okay, who can find this out? 35,000 over 42.1472.
830.42.
The house price. Price is 400,000, and you'll have to pay something down. Okay. So the minimum down payment is usually what?
I don't know.
5% of this. Okay. So I'm going to pay 5% times 400,000.
Do you provide?
You just put percent.
Oh, sorry. Okay, 5.
It's all right.
So 5% times this.
Mm-hmm.
So you make down payment of $20,000. How much you're borrowing?
Borrowing 5.
Or financing, okay? It should be,
How much is
okay, it should be 400,000
Minus 20,000.
20,000. You're borrowing $380,000.
Oh.
And suppose the interest rate, define the rate, I think these days the interest rate would be about 7% per year, okay? Per year. So note that I'm using the numbers separately from the words, okay? Because I'm going to build a formula. So if it is 7% per year, and in the monthly, how much would be monthly? Would be 7% over 12, right? That is your monthly rate. Okay. And this loan is for how many periods?
30 years.
30 years, okay. 30 years or monthly will be here. 30 years will be equal to entire formula is 30 times 12, right? So 360 months. Okay. So we have the amount that we are borrowing, that's called it present value, right? PV. Present value is this, interest rate and the number of periods. That's all we need. Now we have to find out the payment. What is our monthly payment? PMT, okay? Alright. Now here, go to FX, function key here, okay? Click on function key. And go to financial, not SBU, go to financials, okay? And go under PMT, scroll down, PMT here, okay? PMT next. And in this window, say rate. Your rate should be monthly rate, okay? This one, just click on this, it will come here. End par, number of periods will be 360 months. It's here, okay? And present value that you are borrowing today is what present value is, okay? This is $385. There is your monthly payment. Insert. Your monthly payment will be $2,528.50. Future value. And future value of the following ordinary annuities. $400 per year for 10 years at 10%. This will be extremely easy. Future value annuity due, annual ordinary annuity. I'm doing number 97. Future value of this annuity, it says $400 per year for 10 years. So the formula is PMT times future value interest rate annuity. Okay. Now FVA, what is the value of I is 10% and 10 years. 10%, 10 years. So it will be 10 years here. 10% and 10 years. Okay. And payment is how much? $400. Interest rate annuity. And here I'm going to use this chart. 10% will be 15.937. Now, annuity due, we have not done that. Let's see, because the 98 is the same question, $400 per year for 10 years at 10%, but this is annuity due. So one is ordinary annuity, one is annuity due. Annuity due, now I showed you the difference between annuity due and ordinary annuity. Let me show it to you again. Amount, say $500 here, 500 here. And then when you find out the future value, what do you do? We find the future value of each of these separately. This one is here, and this the regular annuity. In ordinary annuity, we make the payment one period earlier here. No payment here. Now, when you find out the future value, look at that. Here, this $500 for regular annuity, how long this money is earning return for?
Ordinary is at the top.
How many years?
At the timeline.
Oh.
10 years? Okay.
For 9.
9.
Oh.
This one is 8.
8.
Yeah, it grows over 10 years, so 9, 8,
Okay.
7, 6, 5.
And so on. Okay. This amount will earn return for how many?
10.
Full 10 years.
Yeah. Because you pay it to that.
This one will be for 9 years, right?
Right.
Mm-hmm.
9 years. And this one for 8 years and so on. So the difference is that with annuity due, money is working with an extra period. Right? Here 9, but here's 10. 8, but there's 9. Okay?
Mm-hmm.
Every amount that we are investing with annuity due, it is D for due, okay? Would be equal to future value of regular annuity FVA times 1 plus the extra period return, okay? 1 plus times 1 plus I. Okay? So FVAD, because the payments are made 1 period early, it will earn return for 1 period. Okay? And that is, we do that by multiplying this by 1 plus I.
It's 6,374.
6,300.
74.8.
0.8. Okay. Okay. So that's the
That's the
regular annuity, ordinary annuity. So find the future value of annuity due, you multiply this by this is 6374.8 times 1 plus 10%, 1 plus 110. Okay.
7,012.
Then the future value of a regular annuity. Because of the extra 1 plus I. Okay, always remember that. So that will be a question on your test. Okay. Same formula. 999. We're finding the present value. PVA is equal to payment times present value interest factor annuity. Okay. Okay. 99. Again 10 years, 10%, $400. Okay, $400 times PVISA, 10% and 10 years. Okay. So get this factor from the chart, present value chart, present value annuity. Okay. 10% 10 years would be 6.1446. Okay. Divided by 6.1446, that would be your answer.
2,457 point
1,457.
0.84.
57.84. Okay. So that's the future value, present value of this annuity. And for annuity due, I think the question 910, it says find the present value of the following annuity due. Same question, $400 per year for 10% 10 years, annuity due. And the formula for annuity due is very similar to the future value annuity problem.
Right. Which is just,
Okay. And I'm going to do it here. PVAD, D for due, will be equal to PVA times 1 plus
1
I.
plus I.
Okay. In both cases, to find, in this case, PVA is 2457.84 times 1 plus I is 10%, 1. Okay. So that would be your answer. Okay, whatever it is. Here on all
That's the
calendars,
answer for
try to solve
present
as many problems
value
as you can.
annuity
Okay?
due.
Because these will be